Hey everyone! So here's going to be our lesson for today for math. It's going to be transformations. So it might have been where you've already started doing this stuff on your lessons from the previous ones, but here this lesson is specifically just for transformations and how to do them. So in our book, which you can reference in your own math book, we have this little grid here. So there's this term up here, congruent, and we have talked about that before. It has to do with the word same or similar. So it says, recall that two figures are congruent if one figure has the same shape and size as the other figure. One way to decide whether two figures are congruent is to position one figure on top of the other. So we're going to pretend that we can just take this and spin it around. Obviously we can't do that because it's a 2D shape, but if we were to peel it off the page and use our imagination just to turn it, would it be able to land on top of this page? So this one, the figures are congruent because if we were to peel this F off, we could flip it around or switch it to land it on top of this F. And if we were to peel this F off, we could do the same thing. To position the left-hand figure, right here, on the right-hand figure, we combine three different kinds of moves. So we're going to want to write this down. So if you're taking notes with me like we do in class, I'm going to write down the word rotate. We all know what the word rotate means, but just to make sure that we are understanding when it comes to transformations in math, it means literally just to turn. So we're going to first rotate this F up. We do this in turn, like quarter turns. So if we flipped it 1, 2, 3, all the way 4, it would be a whole turn, right? 360, you could say. If you turned it a quarter of the way, you could say it's, well, let's just, I'm not going to go into the degrees yet because we don't need to know that yet. So just kind of ixnay that. But we do need to know that we've turned it a quarter turn. The next piece that we need to do is translate. So we know the word translate, like if we asked Ariel to translate something from Spanish to English, or we asked Yana to speak Finnish for us to understand an English word, we would say translate. But in this case for math, it means to slide. So we're going to just like slide it over. So we have flipped our F around 1/4 turn, stood it up on its vertically. Then we have slid it over, but we're not on top of it yet. We're almost there. We have one more piece to go. Can you guess what it is? If you guessed reflect or flip, you were right. So these are going to be our three main things when we talk about transformations. You need to know what rotate means, what translate means, and what reflect means, or reflection. Rotation, translation. So if we are looking at our math book, remember this is all in your book too, we can see that we have flipped it over. We've just, bloop, we have now reflected it onto the other side. So there's going to be a couple of things that I want you to write down if you're taking notes. It's a really good idea to continue taking notes just so you can reference back, but I know some of you do better without taking notes, which is fine. So I'm going to write rotation again down here just to add some more information. I'm going to write turning a figure because it won't always just be an F or a letter necessarily. It could be a number or it could be a shape as we get into it more in depth. So turning a figure about a certain point. So remember, with these videos, you can always pause if I'm going a little bit too fast and you need to catch up on writing. You can always fast forward if you're like, oh, Miss Em, I already know this information. Or if you're like, hey, I don't really even need this video. It's just for your help. If you don't need it, cool. You can do your lesson without it, but if you ever get stuck, you can always reference back to the videos since we're not at school, unfortunately. Next one, again, I'm going to put translation. We're going to say sliding a figure in one direction. It's important. One direction without turning the figure. So it only slides in one direction. We'll see more of that as we get deeper into this. We'll do a practice problem or two just to make sure that it's sticking. It can be a little bit tricky if you're trying to go too fast. So you have to be really literal with it and say, okay, this is going to flip. And maybe even doing the hand motions. Okay, it's going to flip. That way you can really process it before you're going to write down your answer. The last one up here, we had reflect, so we're going to write reflection. Reflecting a figure we're going to pretend like in a mirror. So I'm going to put as in a mirror. Or flipping a figure over a certain line. So in our book, we have the example. Rotations can be described by their amount of turn and direction. So that would be like if I said, Seth, walk to the wall. He wouldn't know which wall I'm talking about, right? I have to be really specific. So if we're looking at this triangle, you can see the dotted line. It started vertical, and then it was flipped a quarter turn, 1/4. It's another way to say a quarter. Clockwise. So if we imagine a clock, we tell time going this way, not this way. This is counterclockwise, going to the left. Clockwise is going to the right. So let's just write that example down here so that way we have it stuck in our brains. Remember, when you write something after you've heard it, it's generally more likely to stick in your brain. Rotations can be described by their amount of turn and direction. Then below here, I'll put clockwise versus counterclockwise. And then we have talked about a quarter of a turn. That's how it starts. It might not just turn a quarter. It could turn 2 quarters or a half, right? It could turn 3 quarters. So if you're like, Sam, I'm not really understanding the quarter things. This is where I was talking about, we were going to talk about degrees in a further length. So I'm going to zoom in here so you can see it. We often use degrees to describe the amount of turn. 1 full turn, like I mentioned earlier, is 360 degrees. So a half turn is 180 degrees. If you've ever seen someone on a bike or skateboard, a scooter, you see those cool things in the Olympics or the X Games. They say, oh my gosh, look at that, 360. They've done 1 full rotation. A quarter turn is 90 degrees. Clockwise, like I mentioned, is the direction the hands of the clock turn, which is to the right. Counterclockwise is the opposite direction. So if you want to write that down so you can understand the degrees part, I highly recommend doing so. I'm going to write that down, but I'm not going to do it right now, so you can skip over that piece if you want, but I would recommend doing it. However, I'm not going to take up your time writing it down. I'm going to just move on to our example problems. So, the first example problem has to do with the number 3. So, we're going to put example here like we do in class. So the 3 was just a normal 3. But our question says, draw the figure, our 3, after a 90-degree clockwise rotation. So, a 90-degree clockwise rotation. Pause the video, see if you can figure out what that is. If you need a little bit of help, that's fine, but try it first. Really try to do it. And then once you've at least attempted or you think you've got it, unpause the video, and then we'll go over it. So we know that clockwise is going the direction that we would tell time, so it's going to the right. We know that 90 degrees is a quarter of a turn. So we're going to move our 3 90 degrees. So if you wrote your 3, it's a bad 3, but if you wrote it like that, you got it. That is a 90-degree clockwise rotation. If you didn't get it, that's totally fine. Remember, it's the first one. Don't need to beat yourself up about it. It's not the end of the world if you don't get it yet. You will get it. Example 2, I'm going to show you the practice problem, and you're going to have to figure out what to do. I'm not going to draw it on my paper. Triangles ABC and XYZ are congruent. Think of that word congruent. What does it mean? Oh, same or similar. Name 2 transformations that would move triangle ABC to the position of triangle XYZ. So we want to see how we can move this triangle all the way over here, and it's sitting right on top. So we don't want to make the triangle sitting on the triangle like this. That wouldn't really make sense. We want to make sure it's right on top. So there's going to be 2 transformations. Super important that you don't just do one. Pause the video, see if you can figure it out, referencing your notes. Are you going to rotate? Are you going to translate? Are you going to reflect? Which of those 2 are you going to use? So, hopefully you attempted to figure it out. So the first step would be reflecting. So you can see down here that we went from this dotted line here, and we went bloop. We flipped it around so it's at least facing the right direction. Then we want to translate, which was sliding it over, so that way it's going to sit right on top of it. So we can see, if you're imagining with me, if we just moved it, it would sit right on top. If you put translate and then reflect, that's totally fine for right now, because you did the right moves, you did the right transformations. It was just a different order. That's fine. Not a big deal. All right, hopefully you're understanding so far. Remember, it takes some time to practice these things. It's okay to not understand. There are plenty of different options for you to be able to figure this out if I'm not helping enough or if I'm not making sense. Khan Academy has really great videos that you can reference since you're on YouTube right now. You can see if Brain Pop has videos on that, because we love our Brain Pop. And IXL, if you're like, wow, I really like this, or I want to challenge myself and get a little bit more done with it, when you're doing your IXL for the day, go to the math. See if you can find the tab that talks about symmetry and transformations. I know it's there because I just assigned it to the 6th graders. So if you want to try that or give some extra practice, fantastic. I would recommend those different options. Our last practice problem that we're going to do. Again, I'm going to show you how it looks. You can look in your book, but remember, when you look in your book, it's hard because it tells you the answer, so I don't want you to ruin it for yourself. Triangles ABC and PQR are congruent. Similar, same. Okay, got it. Describe the 2 transformations that would move triangle ABC to the position of triangle PQR. How many transformations did I want you to do? Hopefully you knew that it said 2 because it's in the directions. Pause the video, see if you've got it figured out. If you've got it, check yourself with me, of course, and then you can end the video. You can be done with it. You can move on to your lesson. You're going to do fantastic. If you're not there yet, don't you worry. Remember, I was always not great at math. I always was really hard on myself. Don't be like 5th grade Miss M. It was not a fun time because it's not fun to be discouraged and get in your own head and think that you're stupid, because you are not. God made you the way that you are. You have talents that He wants you to use. And if math isn't one of them, hey, that's fine. You can join the club with me, but we can unlock those other talents that God has given you. But you gotta believe in yourself first. So, hopefully you have attempted it. The 2 transformations. I'm going to just write it down so you can see it, and then I'm going to show you the picture again. We're going to rotate ABC. How many degrees are we going to rotate ABC? Well, we want to make it 1 turn, so that would be 90 degrees. Did we do it clockwise or counterclockwise? Hopefully you said clockwise. Then that second step, second transformation, translate. We are going to translate the triangle down on this grid. So, that way you can see it since I've already written it down. Rotate triangle ABC 90 degrees clockwise. So now it is going to be facing the same direction as this bottom triangle. Then we're going to translate the triangle down. It says translate the triangle down 2 units. That is just saying that they went down 2 boxes. You can see that it went from like 3 down, right? I don't know how much of that is actually going to matter when it talks about the units. What I'm mostly worried about is you understanding what the transformations are and the steps that you need to take to get to that. So if you're like, units, a little bit too much, that's fine. Don't worry about it. I won't mark you down on your lessons. Just make sure that you're doing the right transformations. Again, if you were to translate first and then rotate, totally fine, because you would have moved down and then you would have flipped your triangle. So if you said translate, rotate, or rotate, translate, you're good. Doesn't matter what order it is in. So now you should be ready to move on to lesson 88. Hopefully this was helpful for you. I'm going to be doing this for your next few lessons as well. If this isn't helpful to you, you can email me. You can have your parents text me and say, you know what, this wasn't great. It was more confusing than anything. If that's the case, that's fine. You don't have to watch the videos. It's not required. It's just for you to get a little bit extra help if you're struggling or if you just need that little push to keep going. Super proud of you guys. You guys are doing awesome on your lessons, awesome on your tests. I just can't even describe the amount of pride that I have for how hard you're working at home, because I know it's hard and I miss you guys so much. I miss the conversations that we have with math. You guys are so intelligent, regardless of the fact if you think you have a math brain or not, because you do. But I will stop my little rant because I could talk to you guys for a billion years about how awesome you are. But hopefully you'll tune in tomorrow so you can see lesson 89. Bye guys. Good job. Proud of you.